This video is about solving a linear system by graphing. So we actually are going to have three methods of solving our systems of equations, and this is the actual first method. Um, However, I will say it's probably not one we usually jump to. It's not always going to work for every single system of equations. So really, we use this if the directions specifically tell us to solve it by graphing, or if we possibly have some technology available where we don't necessarily need to sit here and graph it by hand. So maybe a graphing calculator or using Desmos on the computer. Because we're not sure, we talked about how our solution to our system is going to be where the lines intersect. And if they intersect at a spot on the graph that doesn't have nice coordinates, you kind of just wasted your time graphing them. So really, we're only going to do this if it says to solve by graphing. We're only going to do one question together on this, really, as an example. So we're going to do a brief review of graphing. If you feel you need a bigger review of graphing, you might want to go back and watch our topic 2 video on graphing lines first. But here we're essentially going to make sure that A, our equations are in slope-intercept form. B, then we're going to graph them using our slope and our intercept. And then we're going to find that point of intersection. And what is usually nice also, especially if you have the time, just plug in that point and make sure that it actually works. And then you can hopefully catch any mistakes that you may have made as you did this. Okay, so we have negative x plus y equals -7. I'm going to write that up here. And now I'm going to put that into slope-intercept form by adding my x to both sides. And we get y equals x minus 7. And then my other one, I'm going to subtract x from both sides. So that is 4y equals x is first, so negative x minus 8. I'm going to divide both sides by 4. And this is one where it's a little trickier. So it may be helpful to put that invisible 1 in front of that x. And now I can see, hey, 4 can't go into 1 or -1, but by putting in that 1, I can now see that fraction I'm supposed to pull out and use as my coefficient of the x. So it's going to be y equals -1/4 x. And then -8 divided by 4 is a -2. Okay, so now let's graph them. Our first one, I'm going to do my purple one. Okay, we have y equals x minus 7. The y-intercept is -7. So that would be down there. And our slope, there's an invisible 1 there. So our slope is 1. Remember, we can always take whole numbers or integers and stick it over 1 to make it look like our fraction. And then that is telling us to go 1 up and 1 right. So from my -7 down there, going 1 up, 1 right. And I'm going to keep doing that. And I know it's annoying because there's lots of points, but accuracy is key to this. If your line even veers off a little bit, you're going to have your lines intersecting in the wrong spot. So I'm going to do as many points as I can. You also have a ruler to make your lines more accurate. I'm going to do my best. Not bad. And we have our first line. Now for our second one, our y-intercept is -2. So right there. Our slope is -1/4. And we said when we did graphing, when we have that negative, it makes sense to stick it with one of our two numbers. Doesn't matter which one. I tend to stick it with the numerator, which now means for our rise, if it is -1, it is going down 1, and a +4 for the run is saying 4 to the right. So I go from my -2 down 1 and 4 to the right, and I can see where they're intersecting. I'm just going to do a couple extra points. I'm going to do 1 on this side as well. Oop, that was too many. I did 5. Up 1, 4 to the left, and do my best to connect them. And then we see that where they intersect would be at this point right here, and its coordinates would be 4, -3. And if I were to check it, I ran out of room, so I'm just going to check on the side, okay? Because I don't need to keep it, but negative 4, because I'm plugging in the x of 4, plus negative 3. Does that equal negative 7 for my first equation? Well, negative 4 plus negative 3 equals negative 7. So that one is good. And then for the bottom one, it's x plus 4y equals negative 8. So 4 plus 4 times negative 3. Does that equal negative 8? That'd be 4 plus negative 12. And yes, does equal negative 8. So even if you do it in your head, okay, even if you just, do it on the side real quick, check to see if the answer that you got where they crisscross does actually work when you plug it back in. Okay, so that's how you solve by graphing. Make sure they're in slope-intercept form. Graph your lines, intercept first, use your slope to find your other ordered pairs, and then find that spot of intersection. Make sure you actually write out your ordered pair, and that, because that's your final answer. Don't just, graph them and leave them there. You actually have to give that final answer of the coordinates. And at the bottom, we talked about this in the last video, but just a quick review. If when you graph them, you get parallel lines because they had the same slope at different y-intercepts, that is when your answer will be no solution. And if you graph them and they end up being the same line, that is when it is your infinitely many solutions. Okay, usually you don't even have to graph it at this point because you would recognize what's going on beforehand, but just in case, okay, that is your special cases for this.